Hello everyone, this is problem 103 of Neetcode 150, longest palindromic substring. So we are going to be given a string and we have to return the longest substring that is a palindrome. So basically a palindrome is a word that can be read exactly the same if you reverse it. For example, Bab is going to be Bab if you inverse it. If we take a look at the example 2, well, the longest substring that is a palindrome is BB because BB inverse is also BB. The problem itself in its brute force approach could be quite simple because uh, what we will do is we will simply just go for every single position. So let's say I start at A and then I just add one index. So I go see AB, then I inverse AB and check if BA is equal to AB. No, and then I keep going. So then I have ABA. And is AB equal to its inverse? Yes. So now just compare the length of that current palindromic substring, and if it is if it is greater than the previous longest substring, well, you're just gonna basically set the longest substring to be 3, and then you keep going. Problem is that basically to do so, we are using two for loop. So we're gonna go see for every single position, all the other positions. So this is n squared, and at every single test, we're also gonna have to reverse the string. So this is gonna take total time complexity of big O of n cube. So now we have to do big O of n squared. So this is how we are gonna solve the problem. Okay. So what we will do is that we will take this little trick in mind. So notice that kayak is a palindrome because if you reverse it, it will also make kayak. But notice that if you start from the y here, you go see the value to the right, and you go see the value to the left. You said they are the same, right? And if you keep going, and if you go see that k on each side, you see that it is the same. So this is an observation we can do, is that basically we're just going to start from a we're just going to try to see if every single position can be itself a center, and then we're going to see the value to its right and to its left and see if they're equal. If they're equal, it means that we still have a palindrome. So this way we don't have to actually reverse a substring at every single iteration, meaning that we are going to have a big O of n squared because we're going to go see, in the worst case, all the other characters inside the string. And there's also another case that we have to encounter is what if basically we have like two B's, for example, we don't have one center. So what we're going to have to do is basically just consider this itself as a center and then go see the other values. So we're going to see that A and A are the same, so this will work. So up to here we have a substring of 4 that is a palindrome. But if we keep going, we have a T and an M, which breaks basically a rule, so we will have to return. All right, so that is the logic we're going to use. We're basically just going to go see if every single value can be either a center of 1 or a center of 2, and then we're going to go see its value to the right and to the left, compare them. If they're the same, well, we know that we still have a palindrome. If they're not the same, we know we no longer have a palindrome. And that's basically it. That's the way we can have a time complexity of big O of n squared instead of big O of n cubed. So let's go ahead and code this. So the first thing that we want to do is we want to keep track of the index um, at which basically the first the first character of the palindrome starts. So for example, in the example xtabbam, right, at the end when we return basically the substring, we want to make sure that we return this, right? And how we will do this is by keeping track of that very first value and keeping track also of the length. So by this way, we can simply like return, let's say this is string s is equal to this. So we can simply return s starting at, let's say that this is I. Okay, so starting at I, and this is gonna go basically up to um, I plus the the length of the basically the entire palindrome. So I think you got the concept. This is why we're gonna have a res IDX for like the index you wanna keep track of to start our palindrome. So this is initially gonna be equal to 0, which is a good starting point. We're also gonna have the length. And after this, we are gonna do a for loop. So we're gonna go for basically every single character in the strings we are given. So we'll say for I in the range of, and also let me just create n, which is gonna be the length of s. Right, so for I in the range of n, what I wanna do is that I wanna have like a left and right pointer. So we're gonna have to do basically two while loop because we have two check. The first one is gonna be when we have a single center, and we also want to check when we have a double center, as we saw in our example. So both are pretty similar. When we have a single center, we can basically initially set our left and right pointers to be equal to the exact same index, where in our double center, well, our right pointer will have to be one value to the right, so we can keep track of two characters at a time. And then we're gonna have a while loop, and basically inside our while loop, we first have to ensure that the left pointer is still in bounds. So if this is greater or equal to 0, we have to ensure that our right pointer is also less than n, which is the length of this string. And also we want to ensure that the two characters that we are looking at on the right and at the left are the same, because this is the logic of the problem. So if all of these are true, we want to check if the length of that current palindrome that we have is greater than the previous one that we saved inside reslen. So what I will do is that I will say if basically the right pointer minus the left pointer plus 1. So this is going to give us the length of the current palindrome that we found. So if this appears to be greater than the previous reslen, well, we know that we found another solution that gives us a greater substring that is a palindrome. So this is when we want to ensure that basically the res index. So this is going to be equal to the left pointer, and the res length is basically going to be equal to the current length of our palindrome or substring, which is the right pointer minus the left pointer plus 1. And also in every single round, we want to make sure that our left pointer moves to the left and that our right pointer moves to the right. All right, same principle for the double center. So what we want to check is that the left pointer is still unbound. So if we decrement it every time, we just want to ensure that it is not becoming negative. It can be 0 because there's an index 0, but if it is negative, we have a problem. So something for the right pointer, it still has to be less than the length of the strings, otherwise it will be out of bounds. And also the character at the left side and the character at the right side gotta be equals in order to have a palindrome. So once again, we are going to do the same thing. So we're just going to check if the current length of that substring that we have is this greater than the previous length that we stored. If it is, we're going to basically put the starting index at the left position. And we are going to set that new reslen to be equal to the current length of our substring. And that's pretty much it. Now we can go out of our for loop and we can return basically the string starting at the index res idx, which keeps track of the left pointer of the longest substring that is a palindrome. And I will have basically a bounding index at the res idx plus the res length. All right, so let's test this out. We got an error. I think I forgot an end. Yeah, there you go. So let's test this again. We have an infinite loop, so we don't have a return statement. No, we do have a return statement. So, oh, of course, inside our double center while loop, we also have to move our left pointer to the left and move our right pointer to the right. Okay, so this is basically the logic that I missed out here. And awesome, it works. So I hope you learned from this video. This is a pretty wise trick to save basically a big of n time on our solution. So yeah, the space complexity is basically big of n for the output string. We're not creating extra space though, but a time complexity of big of n squared, which is what they are asking us to come up with. So there you go. So I hope you learned from this video, and I hope to see you in the next one.